This is an example with two populations and a confidence interval, and we're going to do it for the mean. So our formula for this is we need the difference in the sample means. We need either a z or a t, but I'm going to use z because I'm going to say we have known population standard deviation. And then we'll need times the square root of the first standard deviation squared over the sample size plus the second standard deviation squared over the sample size. Okay, so let's suppose we have two banks. We have Sound Credit Union, and we'll make that number 1. And we have Chase Bank, we'll make that number 2. And let's say the average wait time at the credit union is 4.5 minutes with a population standard deviation of 1.2 minutes when we've looked at a sample of 200 customers. For Chase Bank, we'll have average wait time of 4.75 minutes, a population standard deviation of 1.5 minutes, and a sample of 300 customers. And what we'll do is we'll make a confidence, we're going to make a 97% confidence interval for the difference in means. So going through these, the average in the sample is x1, population standard deviation is sigma 1, and this is n1. This will be the sample of the second one, the population standard deviation for the other population, and a different sample size for the Chase customers. Okay, so to find the z, if we're doing 97% confidence, then we have 3% that goes in the tails, and it gets divided by 2, so each tail is 1.5%. If we use Excel to look up this amount, we can look up 0.015, and it will tell us the z-score is negative 2.17. That means this is positive 2.17. So this z is what we'll be using here. Okay, so now we can plug everything in. We need the difference of the means, which is 4.5 minus 4.75. We need to add, let's do the upper first. If we're doing the upper, we need to add 2.17, and then it is multiplied by population standard deviation number 1 squared over 200, and population standard deviation number 2 squared, over 300. And then we work this out. So this difference is minus 0.25, and this whole thing becomes 0.263, and so the whole upper bound becomes 0.013. We repeat it with the subtraction, so it's still minus 0.25, but the whole thing, that whole margin of error gets subtracted off, and we'll get minus 0.513. Okay, so this is the confidence interval for the true difference in the population. And because we're talking about the population, it's mu1 minus mu2, not x1 bar minus x2 bar. And now let's try to interpret this. So if we remember that when they are equal to 0, there's no difference. So our upper bound is 0.013, and our lower bound is 0.513. So we say we are 97% confident that the true difference in means is somewhere between Sound Credit Union has a longer wait time. It's longer if this is positive. A longer wait time than Chase by 0.013 minutes. And, because it's between this amount and Sound Credit Union has a shorter wait time than Chase. When is it shorter? When this is negative by 0.513 minutes. So the shorter takes care of the negative, and I don't repeat the negative there. So it's somewhere between 0.013 minutes longer for Sound Credit Union and 0.513 minutes shorter for Sound. But since 0 is in the middle, that also means they could be the same. All we know is it's somewhere in this range with 97% confidence.